Hello everyone and welcome to the second part of the introduction to conic sections. So before we proceed to the topic for today, let's have a recall, right? What are conic sections? So conic sections are curves formed by the intersection of a plane and a double right circular cone. And previously, first part of the introduction to conic sections, I visually showed you how conic sections are formed. All right. We actually had an experiment like, okay, if this is a double right circular cone and then we have a plane intersect at this part, then we try to rotate or tilt it at that point, what will happen? Right? So yeah, if you haven't watched that video, I suggest you should do it. You should watch that first before you proceed here. All right. So okay, before we end the video at the first part of the introduction to conic section, I actually asked a question. Like, okay, visually we know how they look like, but how about if we have a given mathematic formula? How do we know that it is a conic section or not? And if it's a conic section, what type of conic section is it? Is it a circle, parabola, yada yada? So here it is. We have the general formula for the conic section. So we have ax squared plus bxy plus cy squared plus dx plus ey plus f is equal to 0, where the letters a, b, c, d, e, and f are constants, or basically numbers. Now, for the sake of learning its basic concepts and basing it from the K-12 curriculum lesson plan, the term bxy will not be included in this series. Why though? If you're asking me why. Let me give you first a spoiler, all right? So, what you'll be learning conic sections in the future. So here, first point here, not only you will be learning to identify whether the given formula is a circle or not, but you will also learn how to graph them in the future, right? The circle, parabola, ellipse, hyperbola, these four conic sections, you will learn how to draw them, all right? So these three conic sections, to be particular, parabola, ellipse, and hyperbola, will be drawn either in horizontal or vertical orientation, in which you will learn that in the future. All right. So, okay, these are like the major spoilers that you will learn about conic sections. All right. But let's go back to the topic. Why we will not include BXY? So here's the reason. If we include BXY or a term that has XY in our discussion, then it will be an advanced topic for learning conic section. Why it will be an advanced topic? So here, you will be learning that there will be a given rotation of a conic section. All right. To be particular, parabola, ellipse, and hyperbola, these three, they will have a given rotation of itself. So for example, let's just say I have a parabola. All right. So I told you that in the future, you will be learning how to draw parabola, ellipse, and hyperbola, either in horizontal or vertical orientation, right? So, parabola, for example, you will learn how to draw parabola in this way, like facing upward or facing downward, all right? Or maybe to the right, or maybe to the left. You'll be learning that, like how to draw them. But there will be an instance where if you include BXY, there's a chance that your parabola would look like this. It's a diagonal oriented parabola. It would look like this. All right? Or maybe it would look like this. As long as it's diagonally oriented, you get the idea. So, okay, what of it if it's diagonally oriented? In fact, it's actually interesting to know if the parabola is oriented at that way. Am I right? Yes, it is interesting. All right. But here's a problem. You need to use some trigonometric topics for you to know its rotation. So, for example, okay, at this parabola, okay, what would be the angle of rotation for you to reach the parabola in this position? Like at what angle, if you're going to rotate it, it will become like this. Okay? Similarly, in this case, okay, if we have this parabola shape, now here, what will be the angle of rotation where it will reach the location or position of the parabola in this way? So there, you will be using some trigonometric topics for you to know its rotation, which is advanced because we will be learning trigonometry soon after we discuss conic sections and others before it. So with that, it is decided that we're not going to include BXY. All right. If we want to, then I think I'm going to make another series of precalculus about conic sections. But that would be like, it's not basing it from K to 12 curriculum, Philippine K to 12 curriculum. All right. So yeah, maybe I might discuss it soon. But for now, let's focus on this. Okay. In fact, this is actually a basic introduction to conic section, which is much better. So due to this will be our general formula to focus on. All right. We will focus on this instead. AX squared plus BY squared plus CX plus DY plus E is equal to 0. Where A, B, C, D, oh wait, there's no F here. It's only E. Okay. There you go. E are constants. All right. But hey, again, okay, again, if you're asking me, what is the general formula of the conic section? It's this, okay? This is the answer, okay? This is the answer. This is the general formula of the conic section. That's it, okay? That's it, all right? It's just that for basic learning, we're not going to include xy, only x squared, y squared, x, y, and e as a constant term, okay? So yeah, again, okay, if I ask you what's a general form, it's this, okay, this one, okay, this one, okay, that one, right, that one, okay. And if you're asking me if that's the case, why are we focusing on this one? Because I already explained to you, if we put x, y, it will be an advanced topic, okay. So for basic learning and to basing it to the K to 12 curriculum, we're going to focus on that part. Okay? That part. Don't for just forget the xy, just don't forget x squared, y squared. X, y, and I constant term. Okay? So that's it. All right. So yeah, we focus on x squared, y squared, x, y plus e. Okay, okay. So yeah, let's go back to the topic. All right. We want to know if it's a conic section, which I think we already know it's already there. Okay. If it looks like that, that's already a conic section. But how would you know, to be particular, if it's a circle or not? So that is what we're going to discuss today. All right. How to generally identify whether the conic section is a circle or not. All right. Please don't forget about this. Generally identify, or just don't forget the word general identification. I'll explain why it is a general identification, not an exact identification. Okay? I will explain it to you later. Okay, let's start first with the circle. So for circle, the formula, it looked like this. Ax squared, ay squared, plus cx plus dy plus c is equal to 0. So what does it mean? It means that the coefficients of x squared and y squared should be the same in terms of number and signs. Okay? What do I mean by coefficient? For example, I have 2x. What's the coefficient of this term? Okay, what's the coefficient? When I say coefficient, I meant the constant, okay, or the number beside the variable. So here in this term, we have 2x, right? So what's the constant here? The constant here is 2. So that constant is what's called the coefficient. Okay? So again, the number beside the variable is the coefficient. All right? Just a short recall. Okay, so for example, we have x squared plus y squared. Now take a look. X squared is just the same as 1 times x squared. And y squared, similarly, is just the same as 1 times y squared. Now take a look. Both of them have the same number, and both of them are positive. So the same signs. So the same number, the same sign, that's a circle. That's it. All right? Same number, same sign, that's the circle. Another example, 2x squared, 2y squared. You see, we have two numbers that are the same. 2 for x squared and y squared. And both of them are positive. So it is circle. All right? Now lastly, we have negative 5x squared minus 5y squared. Now take a look. Negative 5x squared, negative 5y squared. So the same number, 5 for x squared, 5 for y squared. And both of them are negative. So it is a circle. Okay? So remember, circle, the coefficients of x squared and y squared should be the same in terms of number and signs. That's it. Now, what if it's a parabola? You will know if it's a parabola if you have this given formula. All right? Ax squared plus bx plus cy plus d is equal to 0, or ay squared plus by plus cx plus d is equal to 0. What does it mean? It means that either x squared or y squared exists, but not both. In other words, only one of them exists. If it's only x squared, parabola. If it's only y squared, parabola. If it's x squared and y squared, that's not a parabola anymore. So for example, we have x squared plus y minus 5x is equal to 0. There is no y squared here, only x squared. That's already a parabola. Another example, negative y squared plus 1 is equal to x. We have only y squared. There's no x squared. Parabola. And lastly, negative 4x squared minus y is equal to 20. We have 4x squared. We have the term that has an x squared, but there is no y squared. Parabola. So bottom line, either x squared or y squared exists, but not both for it to become a parabola. Okay? So that's it. Now, how about for ellipse? So for ellipse, this one, ax squared plus by squared and yada yada, is just the same formula as what we are basing on here. All right? But the reason why I put it there, because there is a reason. Okay? How would you know if it's an ellipse? So basically, what does it mean is that the coefficients of x squared and y squared are not the same in terms of number, but the same signs. Okay? So numerically speaking, they're not the same, but signs are the same. For example, look at 2x squared and y squared in the first equation, or first example rather. We have 2 for x squared and we have 1 for y squared. Numbers are totally different. We have 2, we have 1. Okay. But you see, both of them are positive. Ellipse. That's it. All right. Another example. We have 5x squared, 20y squared. All right. We have 5 for x squared and 20 for y squared. Not the same number, but the same signs. Both of them are positive. It's an ellipse. All right. Lastly, 8x squared plus 3y squared. Wait. Let me erase this one. All right. There we go. 8x squared and 3y squared. Both of them are not the same in terms of number, but the signs are the same. So that means it's an ellipse. That's it. So bottom line for ellipse, numbers not the same, but signs are the same. Okay, it could be both of them are positive or negative. Now, lastly, how about if it's a hyperbola? So if it's hyperbola, if you're going to take a look at the formula here, ax squared minus by squared and yada yada. Or we have negative ax squared plus by squared yada yada. So what does it mean? It means that the coefficients of x squared and y squared may have the same numbers or not, but their signs should be opposite to each other. Okay? It doesn't matter if the numbers are the same. Okay? If it's the same, okay. If it's not the same, okay. But the signs should be not the same. For example, x squared minus y squared. Numerically speaking, they are the same. For x squared, we have 1, right? And for y squared, we have 1 as well. But you see, for y squared, it's negative, while for x squared, it's positive. So both of them are not the same in terms of signs. Therefore, that is a hyperbola. Okay? Another one, we have 2x squared minus 5y squared. Okay, so if you're going to take a look, both of them are not the same in terms of numbers. Okay, now the signs though, are they the same? No, because x squared is positive, y squared is negative. So it's a hyperbola. And lastly, we have the last example. Oh wait, no. Negative 10x squared plus 10y squared. Now, both of them, they are the same of, both of them are the same of numbers, 10 and 10. But one of them is negative and one of them is positive. So not the same signs. So it is a hyperbola. So for hyperbola, it doesn't matter if the numbers are the same or not, but the signs should be opposite to each other. All right? Then there's one more thing I would like to include, the non-conic sections. Like, what if we have a given formula, but it doesn't look like a conic section? For example, this one, ax plus by plus c. This is not a conic section. In fact, this is a general form for a linear graph. In other words, x plus y plus a constant term is a graph for lines. Lines, like, those diagonal line or horizontal line or vertical line. Yeah, lines, all right? So, point being, to make it easy for you to know if it's a conic section or not, if you see that x squared and y squared do not exist, wait, yeah, do not exist. Am I right? Is the grammar correct? No, no, yeah, it's correct. Yeah. Anyway, if x squared and y squared do not exist in a way that it would look like this, it's not a conic section. Again, if both x squared and y squared do not exist, then it will not be a conic section. So for example, like this, x, y, y, x. But what if it's just only one variable? Like for example, x minus 4 is equal to 0. Or maybe 1 plus y is equal to 2, or maybe 0 rather. Or what if it's just number at all only, you know, like 1 is equal to 0. Or maybe what if only variable, like y is equal to 0. These are not conic sections, okay? These are not conic sections, all right? So let's have a summary, right? So that we can have a refresh or recall. So for summary, circle, you will know it's a circle if the coefficients of x squared and y squared should be the same in terms of number and signs. Okay? That's for a circle. Parabola, either x squared or y squared exists, but not both. Okay? Only one of them. For ellipse, the coefficients of x squared and y squared are not the same in terms of number, but the same signs. And lastly, for hyperbola, the coefficients of x squared and y squared may have the same numbers or not, but their signs should be, here we go again, wait, should be opposites. Let me just write it down here, okay? Opposites to each other, all right? Let me erase this one, right? That's it. Should be opposite to each other, right? Let's have a practice, all right? Don't worry, I will create another video about generally identifying whether if it's a circle or not, okay? But before I do that, let's have a practice, okay? So here we go. So we have 2x squared plus 3y squared minus y plus 5x plus 1. Now, the focus here is look at the x squared and y squared. Now here we have 2x squared and 3y squared. So numbers, in terms of numbers, we have 2 for x squared, we have 3 for y squared. So numerically speaking, they are not the same. 2 is for x, 3 is for y. But both of them are positive, right? Both of them are positive. So therefore, the answer for this problem, for this first practice problem is ellipse. Okay? It's ellipse because not the same numbers, but the same signs. Let's proceed to the second part. X squared plus y squared minus 4x and yada yada. X squared and y squared. Both of them are the same of numbers because both of them have a coefficients of 1. And at the same time, they have the same signs. The same number, the same signs. So it's a circle. All right? Here we go. Negative 2x squared plus y squared plus 2x is equal to 0. Negative 2x squared, y squared. So here, in terms of numbers, they are not the same. And here's the thing, not only that they are not the same in terms of numbers, but the signs as well are not the same because we have negative for x squared and positive for y squared. So this is a hyperbola. Okay, this is a hyperbola. All right. Here we have x plus 2y plus 2 is equal to 0. If you would notice, there's no x squared and y squared. So remember, again, okay, again, if x squared and y squared do not exist, there will be a non-conic section shape. So we can say that this is NA or none of the above. Okay, so you can just say none, much better, none. All right, so let's proceed here. 4x squared plus 4y squared minus 2x minus 8 is equal to 0. 4x squared, 4y squared. Both of them, if you're going to take a look, have the same numbers and the same signs. Both of them have the same number, which is 4, and both of them have the same sign, which is positive. So this is circle, right? This is circle. Here we have x plus 2 is equal to 0. Again, there's no x squared and y squared. So if there's no x squared and y squared, just simply put none. Or none of the above or none. That's fine. So here, we have 5x squared minus 2y squared. Now, if you're going to take a look, okay, despite that they have different terms like negative 50, wait, is that negative 50x? Positive. So yeah, going back, uh, despite that they have 50x minus 8y minus 9, we will only focus on the x squared and y squared. Now take a look. 5x squared minus 2y squared. Both of them do not have the same numbers. 5 is for x squared, 2 is for y squared. And here's the thing. Not only, once again, they're not the same in terms of numbers, but they are also not the same in terms of sign. We have positive for x squared and negative for y squared. So the answer for this case is hyperbola. Okay? Here, second to the last. 4y squared minus 7x minus 8 is equal to 0. We do not have x squared here, only the term y squared. So automatically, this is a parabola because a parabola only have x squared or y squared. Okay? Now, lastly here, I think you already know the answer. We have 10x squared minus y is equal to 5. So there's no y squared, but we have x squared, which is 10x squared. So this is also a parabola. And that's it. We actually have a practice for general identification of conic sections via general formula. All right, but don't worry, I'll make another video about it. Let's have another practice video for this one. But let's go back. Okay, before we end this video, let's go back. Okay, I mentioned that do not forget this phrase, right? Generally identify. Okay, or just don't forget the word general identification. Why is it called general identification? Okay. When I say general identification, meaning commonly, this is how they look like. Commonly, this is how they look like. So what does it mean? It means that there is a chance that you know it's a circle based from the technique that the one I showed to you, but in reality, it's not a circle. So what's the point then? What's the point then in discussing this? The point is that we may never know exactly if it's a circle. Okay, exactly. We may never know. Because there's a chance that even if it looks like one, there's a chance that it's not a circle. Okay? But as generally as possible, at least we get the idea how they look like. Okay? So here's the question. How would they know if they are exactly a circle, a hyperbola? How are we going to know that? We will know that in the future.